Welcome, welcome. So in this video, we'll learn how to prepare and standardize Fehling solution. Now Fehling solution is actually mixture of Fehling solution A and Fehling solution B. Fehling solution is used to determine the reducing sugar in any sample. We are also using it for determining lactose content in milk. And if we define reducing sugars are those sugars which contain free aldehyde or free cation group in their structure and can reduce Fehling solutions, tolerant reagent or Bendick solution, or in other words they can reduce the metal ions present in them in alkaline conditions. So they can reduce either copper like that in Fehling solution, or iron, or silver. Also silver is there in the tolerance reagent. So in this video we will study how we can prepare the Fehling solution and then how to standardize it to determine its strength, and to standardization we are making use of lactose standard. Okay, lactose solution is given to us with concentration 0.5%. So this is known. So from this we will be able to calculate the strength of the Fehling solution. A Fehling solution is used for the estimation of reducing sugars. Is generally prepared by mixing an equal volume of Fehling solution A and Fehling solution B. To prepare Fehling solution A, dissolve 34.639 gram copper sulfate pentahydrate in water and make up the volume to 500 ml. Filter using ordinary filter paper. Okay, so this is how Fehling solution A is to prepare. So initially it was designed that scientifically it was this way, that 10 ml of Fehling solution rather 1 ml of Fehling solution will exactly react with 5 milligram of lactose. So initially it was scientifically it was designed in this way, that it was decided in this way that 1 ml of Fehling solution will react exactly with the 5 milligram of lactose. So in this way, this is around 0.1 normal. So this way, this is decided that this much gram of copper sulfate 5H2 is to be taken and make up the volume to 500 ml, and this will provide sufficient copper ions for the reaction to take place. And if you use less, obviously that all the reducing sugar won't be covered, and if you use more, then even after reacting with reducing sugar, the color won't change. Okay, now similarly for Fehling solution B, you have to dissolve 173 gram Rochelle salt. Rochelle salt is nothing but the sodium potassium tartrate. And dissolve 173 gram Rochelle salt in about 300 ml water, and in another beaker you take 50 gram NaOH in 100 ml water, mix and make up the volume to 500 ml. Okay, so this way you will have the Fehling solution B. Now this you have to keep it for 2 days and then filter it using ordinary filter weight. So to have them to make the solution clear, and that to make the tartrate alkali complex stable, so you have to allow it to stand for 2 days and then filter it using ordinary filter paper. Okay, so now Fehling solution B is ready, Fehling solution A is ready. You mix them in equal quantities as per your desired volume which you require. That way you will have the Fehling solution. And now this Fehling solution is prepared. Now you want to determine its strength, and that strength you will determine by using standard lactose. So what are apparatus and glassware? You require conical flask, volumetric flask, burette, pipette, Bunsen burner you require for heating. And then the reagents which are required are copper sulfate, sodium potassium tartrate, which is Rochelle salt, sodium hydroxide, lactose standard, that is 0.5% lactose standard is given to you. Methylene blue solution is required. Okay, now let us see the reactions. What are reactions which are taking place? So let me tell you quickly the principle. So when copper sulfate is made alkaline, it gets converted to cupric hydroxide, and this cupric hydroxide react with sodium potassium tartrate to form the complex, and this complex for the sodium potassium tartrate keeps the cupric hydroxide in the soluble form. So this can be taken as that it is soluble cupric hydroxide. So this sodium potassium tartrate keeps the cupric hydroxide in soluble form, and this, when you heat the cupric hydroxide, you will have the cupric oxide, This is cupric oxide, and which when react with the reducing sugar, so this will reduce the cupric ion here to cuprous ion here. So we will have the cuprous oxide brick red precipitate at the end point. This reducing sugar we are taking in the burette, and then from the amount of titer value which we will obtain, we will be able to know the strength of the Fehling solution. So again repeating that you what are the reactions which are taking place that the copper sulfate is made alkaline get converted to cupric hydroxide. This cupric hydroxide when reacted with sodium potassium titrate form a complex which keep the cupric hydroxide in soluble form, so it behaves as if it is soluble cupric hydroxide. And then when you heat this soluble cupric hydroxide, you will have cupric oxide, and this cupric oxide is reduced by reducing sugar to cuprous oxide, which is brick red in color with the end point of the titration. Okay, so now let's see the step by step to how to standardize the Fehling solution. So you pipette 5 ml of Fehling solution A, 5 solution of 5 ml of Fehling solution B, using two separate pipette in 250 ml earthenware flask. Okay, so you have pipetted 5 ml of Fehling solution A, 5 ml solution B, and, by using two separate pipettes in a 250 ml earthenware flask. Then you will wait to prepare 0.5% of lactose solution. You will take 1.3 gram in little water and then dissolve it in and transfer it to 250 ml volumetric flask, make up the volume of distilled water. So if you see the 0.5% of 250 ml is around 1.3 gram. So this way how you are preparing the 0.5% solution of lactose, which is around 0.0138 normal. This will be 0.0138 normal. So this is the standard lactose. So from this concentration you will calculate the strength of the Fehling solution. Now fill up a burette with standard lactose solution and connect the burette end with an offset tube to keep the burette tube out of steam. Okay, now heat the content of the flask to boiling over burner or heater and maintain moderate boiling for 2 minutes. So you boil the content for 2 minutes. So here you see this is if you have taken 5 ml Fehling solution A, Fehling solution B in this conical flask, and then you heat it, boil it for 2 minutes. You will have a slightly brown color like this. To prevent punting, you can add the boiling chips or boiling beads. Then you add 3 to 4 drops of methylene blue indicator without removing the flame. So you don't need to know. So if you add methylene blue here like this, the color will be like this. Okay, so after heating, this is boiling for 2 minutes. After boiling for 2 minutes, the color will be like this. And then you add a methylene blue indicator, and then you will start titrating with the sugar. So titrate the content of the flask, the standard lactose solution from the burette until the blue color disappears. The blue color will get disappear, and the bright big red color of the precipitated cuprous oxide will appear. So bright red precipitate of cuprous oxide has appeared. So this is the end point. Now from the note the volume of lactose solution required for the standardization of the Fehling solution. So how much lactose solution has been used for standardization Fehling solution, you will note it. And this is called the preliminary titration. Why it is preliminary and why we are going for it? Because we want to save time in boiling, because if we are boiling for an extended period, then instead of that your cuprous form will get converted to cupric form, that we don't want. And also that there may occur decomposition of the reducing sugar. Methylene blue may get immaturely colorless. So because of these reasons, so we have to to save the time in boiling, we will able to know how much ml of lactose standard is initially required. Say 15 ml is required. So what we will do, we will add for the main titration, we will add 14 ml, 1 ml less than this, that is 14 ml we will add, say, and then we will boil the content for 2 minutes like the way we did it in the original titration. Then we will add 3 to 4 drops of methylene blue indicator and continue heating and complete the titration within 3 minutes. And this titration again to be completed within 3 minutes. Reasons are that we want that decomposition of the so one reason also that decomposition of cuprous, that is the Fehling solution take place if you heat it for prolonged period. So that is why once we know that 15 ml is required, we can add 15 ml and save the time in boiling, so that decomposition of Fehling solution not take place. And also that titration to be completed within 3 minutes. Reasons again are the same, that we want to we don't want that the cuprous form that has been formed get reconverted to cupric form. And also we want that if you boil for extended period of time, then they may happen reduction of the reducing sugar or the decomposition of the reducing sugar which may happen. So you will know the volume of the title. So title say you are obtaining the V2 volume as here, and now we want to calculate the strength. So N1 V1 equal to N2 V2. So say V1 is the volume of the lactose solution that has been used, to the titer value. N1 is the normality of the lactose solution, which have you seen here, it is 0.0138. So if we put here, it is 0.0138 normal volume you have got from the titer value, and this V2 is the volume of Fehling solution that has been used. So how much you have taken? 10 ml you have taken. So you put these values and you will have the normality of the Fehling solution. So by this you have known that about how much the strength of the Fehling solution. And in terms of normality, if you want to calculate in the terms of percentage or the concentration, so C1V1 equal to C2V2 can also be written. So you know concentration is 0.5%, volume whatever titer value you have got divided by 10 ml which you have taken. So C1 percentage, that is Fehling solution percentage, in this way can come. So in percentage also you can calculate the concentration of the Fehling solution, or you can also arrive at a factor. Factor means that how much 1 ml Fehling solution is equivalent to how much milligram. 1 ml Fehling solution is equivalent to how much milligram of lactose. Okay, so that means, okay, so we can also calculate the factor F, which is meaning that how much 1 ml Fehling solution is equivalent to in terms of quantity, or the milligram of lactose. Say, so here we have seen that 0.5% lactose solution we have used, which is equivalent to 5 milligram per ml. Okay, say 25 ml has been used of it. So 25 into 5, that is 125 milligram of lactose have been used, and this has been used for 10 ml Fehling solution. So 1 ml Fehling solution will be equivalent to 12.5 milligram lactose. So in another way to express the concentration or the strength of the Fehling solution. So now since we know the strength of the Fehling solution, it will be called as standard Fehling solution. So Fehling solution is always standardized with using a lactose standard. And what are the reaction taking place? What is the procedure to standardize it? How to prepare the Fehling solution? That we have seen in this video. Thank you.